Thanks for joining us for another episode of DPC Radio. This episode was recorded live in Amsterdam at the Dutch PHP Conference 2012. For more information about the Dutch PHP Conference, visit our website, phpconference.nl.
All right. Hey, everyone. I think you can all hear me? Yeah. All right, great. I'm not so sure whether the mic or like... No, you can't hear me? Not at all? Seems to be working, though. All right. Yeah, I hope you all still have some place left somewhere in your head for a bit more information after these 2 days filled with lots of really interesting talks. I'm going to be talking about Composure, a new way to manage dependencies in PHP projects. First, start a few words about myself. I love working on open source projects, just like Composure. I've been working on PHP for a bit over 7 years now. And I recently launched a company called Formatic where we offer managed PHP hosting. So if you guys need anything relating to forums, do check that out. PHP is actually the background for how I got into Composure. About a year ago, we started working on Composure after previously deciding to switch PHP to use Symfony 2. And we realized that we really need a proper solution to managing plugins within PHP. And at the same time, the Symfony community really needed a better way of handling their dependencies for projects. So we got into talking and decided that rather than building some custom solution just for this small problem that we personally had, we should really try and approach the problem in a more generic way that will be useful to all PHP developers. So that's how Composure was born, which was started about a year ago. So it's a really young project. I'd like to give you all an introduction into what it is, how it works, how you can use it. So I hope you'll all find how useful it is and try it out yourself after this talk. To begin with, there's a little difference between package management and dependency management from our perspective. With a lot of package management tools, like you maybe know from using Linux, you do something like apt-get install and some package name. So you install packages, and you have some set of install packages, and you add a new one, you update one, you remove one. While we always define the entire set of dependencies. So we don't think about, I want to add this one new package, but rather, let's define the entire set of dependencies that my project has, and manage the set of dependencies as a whole, and not lose track of which other dependencies there are. You'll see how this works out in a bit. So first, package management in PHP. Who here has used Pair so far? Right. So who here installed PHP unit with Pair? Who here is using Pair for anything else? Yeah, that's what I thought. Like a few people, but very, very few. And yeah, this is just like one example of why people have a problem with using Pair. It's just sometimes rather cumbersome to set up, and people just, it's not quite that easy to get started. You can do a lot of really cool things with it, but it's not very approachable to a lot of the PHP developers out there. So Composure actually consists of a number of different projects. The source code for all of these you can find on GitHub. There's Composure itself, which is really a command line tool to install your dependencies for the project, which is meant to be as easy to use as possible so that we avoid this problem of people trying to figure out how to get this to run at all, having to debug all these different problems with installing packages. It installs the dependencies, as I said, for just this one project rather than system-wide. This is something you can do with Pair, but that's rather, again, something that people are just not aware of. On the contrary, Composure is all about managing dependencies just for one project. And it'll install these locally inside of your project rather than globally making them available to all of your projects, which makes it a lot easier to understand the scope of the packages you have installed. We also try to enforce certain best practices. PSRs, or PHP standard recommendations. For example, there's PSR 0, which is an autoloading standard, which I think a lot of you have come across by this point. There are two new ones since a week ago that define certain coding standards or coding style guidelines. SPDX is a standard for license identifiers to make it easier to deal with licensing within your package management. So if you build an application, you use open source packages using different licenses, you typically have to think about which ones you can actually use, and SPDX is a way to standardize the identifiers used for licenses so that you can actually usefully filter by license and identify which packages follow which license. Semver being a versioning standard that we encourage. So then there's Packagist, which is sort of one website where anyone can submit their packages with an easy-to-use search interface. So it's like the one place to go and find packages that you might want to use. It is open to everyone. You can really just enter your GitHub URL to some repository. It'll automatically fetch this repository and make the package available to Composure on there. I'll get to that later. This is an example of what it looks like. This is like one package twig, the template engine, just so you get an idea of how this looks. In the top, you have the search bar where you can just type in keywords that'll search through all the packages. And like you see on the top right, we're actually counting installations now. So you get an idea of how popular a package is, if this is something that's commonly used, or if you publish something yourself, you can get an idea of, are people actually finding this useful? Do people know about this? Are they using it? So that's just like a general idea of what those pages look like. Apart from Packagist, there's a second tool to build a package repository called Zetis. That's just mostly useful for smaller projects, especially closed source ones. Because like we encourage you to publish whatever you can as open source, but there's obviously valid reasons to keep certain things for yourself, maybe inside of your company. And you won't want to submit these to packages because they'll suddenly be available to everyone. So you will have to run your own repositories for internal company use, for example. And Zetis is the tool to use there. It has similar features. You can specify Git repositories that should look at and get your Composer packages from. And it'll dump a file very similar to what Packagist provides, and you can easily use this with Composer to install your closed source local packages. And well, lastly, if you don't trust me that this is something very useful to use, it's a young project, but we've got a lot of people who've had really positive experiences with this project so far. So if you don't trust me, trust these people. So just after that's the general overview of what kinds of things Composer consists of. But let's get into like how do I actually use it? And the first way that you will probably get in contact with Composer is if you want to use some project that uses Composer. You want to install something that already exists. This example, I used the Symfony Standard Edition, which is like the standard way of creating a new Symfony application. So for example, you use Git to clone that repository. You go into that directory. And the next step is you install Composer. Composer ships as a FAR file. There was an interesting talk on FAR files just now, so maybe a few of you saw that. Composer is a FAR file. The problem with FAR files, as was mentioned in that talk, is that there are a couple of ini settings that stop FAR files from working. And typically, there aren't any useful error messages. So instead of recommending that you download the FAR file directly, we recommend that you run this little curl line, which is available on our download page to copy and paste. Which runs a little PHP script that checks for these INI settings and makes sure that your PHP is configured correctly. If it isn't, it'll give you instructions on how to configure a PHP so that it can execute FAR files. And then it downloads the Composer FAR file, which is what you were actually trying to do. And that way you can be sure that once you try to run it, it actually works. So that's how you install Composer. And then how you use Composer is exactly one line. You run php composer FAR install. And that then finds the dependencies of this project, their dependencies. It resolves which versions it has to download of each of these. It downloads all of them, unpacks the code, makes it available for this project to use. So what it does in this step is create a vendor directory within your project. It's configurable how this is called. The default is vendor. And inside of this directory, it downloads all these packages that your project required. They're separated by namespaces. So certain vendors, like in this case, Symfony, have multiple packages that you downloaded. This is shortened a bit. There would obviously be a few more. Or Twig consists of 2 separate packages. And it'll just extract all the files in those packages into this directory, easy for you to use. There are 2 special, one special file and one special directory here. Autoload Php is a very simple autoloader that is able to autoload all of the packages that you installed. I'll get into how that works a bit later, but it makes working with Composure a lot easier. And the Composure directory contains a bunch of metadata about the packages that you have installed, which you'll typically not have to use. But just so you know what that directory is for. There's an even easier way if you want to start a project that is actually available as a Composure package itself. The Composure create project command. So for example, with our Symfony project, we could instead have just gone and typed PHP Composer for create project Symfony Framework Standard Edition. Symfony Framework Standard Edition is something you would have found in packages through the search, so you know how this is called. And that will actually do the git clone for you. It will then identify the dependencies, install them, and do all of that in one step for you. So it's an extremely easy way to start a new project based on some sort of framework that provides you with a package like this. All right, so we've seen how they're being downloaded, how you use that, but how do you actually define your own dependencies? So either you want to start editing the dependencies of some project that you're working on, or you want to start your own project. And the way to do that is with a Composure JSON file. So again, we're trying to keep this very simple to understand, very minimalistic. It's a JSON file in which you simply define which packages require and which versions. For the versions, you can specify constraints rather than exact versions. Like you see in these examples, you can do something like 1.* to install any variant of the version like 1.0.0 or 1.0.1. That way, you can specify that your package is compatible with the API of this package in this particular set of versions without having to say that it only works with one particular version. In addition to defining your package dependencies that you regularly use, you can also define further dependencies in the required dev part that you only need during development. So for example, if your test seed relies on an additional package, like this VFS stream to mock file system accesses, then you can use the required dev key to make this package install only in development mode. And you use install --dev to tell Composer to install these additional packages so that you can run tests, have useful tools available for development. These will not be installed if this package is used as a dependency within some other project, and that way you keep your dependencies to those that you really need for other people, if you're publishing a library, for example. Composer can also, rather than just downloading the file from like a zip file or some tarball, clone the repositories of your dependencies for you. So if you'd like to actually work on one of your dependencies, make a change, commit it. That's easily possible. Just use -- prefer source to get a git clone, SVN checkout. You can use Mercurial, which is integrated as well. And you'll have the repositories right inside of your vendor directory. And that's something that PHP developers like to do a lot, just like go in there, edit it. And this way you can actually still commit it correctly. And you won't have problems with having like small changes in there which aren't actually stored in the packages when you update. But using this feature, you can actually work on your dependencies within your project. All right, so that's how you would define the dependencies of a project. If you want to then actually publish this, for example, if it's a library or some kind of application that other people might want to use, you will want to add a bit of additional metadata. So the first obvious thing is you will want to give your package a name. So it's findable on packages, for example. We recommend that you always split your package name into a vendor name and the package name. For example, if your package name is just something like mail for an email library, then it's really bad for identifying this package amongst different projects unless you specify a vendor name as well to make clear that this is, for example, like the Zen framework mail package rather than like the Zatter components mail package. I think both projects have something called just mail. That's why we recommend using this scheme for names. You can further define a description and keywords which will be available in the full text search that you do on packages, making it easier for new users to find your packages. The type identifier by default is just library. can be used if you work on a project that has a larger, for example, plugins. In our case with PHP, we have what they call extensions there. So we have a type PHP3 extension. This, for one thing, allows filtering packages on Packagist. That doesn't quite work at the moment. That feature's sort of missing, but like it'll allow filtering packages in search. It allows defining custom behavior during installation. So you could have a custom installer for a particular type, like our PHP plugins will probably have to make certain database changes on an installation. So those could be executed automatically based on this type. So that's what the type is for. And then additional information is mostly there, so you can see it on packages like the homepage for this project, information about the authors. The require is exactly the same as in your project definition. This is actually very important. The project definition and publishing as library, the metadata file is exactly the same. If you're just losing it locally as a project, this metadata will just be ignored because it's useless. But all the information about requirements that you have is exactly the same. And the last bit there is, again, about this autoloader. I mentioned that Composure generates an autoloader. And using this key, you can specify how your project is being autoloaded. And if you do that, it'll automatically generate autoloading for your classes inside of your project. Again, I'll show how the code for that looks a little bit later. Another problem that people commonly run into with package managers is that if you work in a team, one person might have a slightly different version from the rest of the group. For example, he joined your company just like recently, and he installed things recently, but everybody else is still using a slightly older version. And while they're technically supposed to be compatible, because it's just like a minor bug fix release, they accidentally broke backward compatibility somewhere. And if you've ever tried to work out this weird error that doesn't seem to be caused by anything obvious, just on this one developer's machine, and then you end up, after searching for a couple of hours, realizing that there's this one bug fix release that he has installed that's slightly newer than other people have on their machines, then you'll realize how annoying it can be to track these things down. So Composer's solution to this is the Composer log file. So when you run Composer install, it will actually, in the first time, it will generate this log file, which will store which version exactly you are using. So as I showed earlier, you can use something like 1.*, in which case any version like 1.0, 1.2 could be installed. But the log file will contain only the exact version that was actually installed. So if 1.1 was the newest version at the time, the log file will contain 1.1. Now that this log file is generated, and please do commit it into your source code repositories. Do not add it to git ignore. I see this a lot. This log file is meant to be committed and made available to your other team members. If other team members then check out your repository and run Composer install themselves, it will ignore the Composer JSON file and instead use the exact versions that are in the Composer log file, making sure that everyone on your team is using the exact same version. This is also useful if you're, for example, publishing an application to make sure that the dependency versions used by your users are in fact the ones that you tested your application with, right? So if you want to do an update then, you can run Composer update, which works very similarly to install, with the exception that it deletes the log file and recreates it. So if you do that, all the dependencies in the log file is updated, and the next time another developer runs Composer install, it will update for him as well. But this way, you have a very explicit way of saying that you really want to use a newer version of the package. And you can make sure that after running Composer update, all your tests work, that everything is running correctly. And then you commit the log file once you're happy that that your project actually works correctly with the new versions of all your dependencies. Right. I think I mostly mentioned that. All right, so the autoloading that I've mentioned a few times now. There are different ways of defining autoloading. The recommended way is to use PSR0, which I've brought up before, which is the standard way of mapping namespaces as well as class names to file names or paths. So in this case, you define which namespace you will be able to locate in which directory within your project. So as you know from many projects, you have something like a source directory or a lib directory, and this makes it easy to autoload according to PSR0 from that subdirectory within your project without problems. The alternative, either for older projects or for people who for some reason do not want to use PSR0, which by the way includes the old pair prefix naming standard, that's a subset of PSR0, you can use the class map, and you can simply specify either a directory or a set of directories or files, and then Composure will simply read all of these files and find all the classes defined therein and generate a complete class map for all of these classes so that those can also be autoloaded. And lastly, if you're using projects, like older projects, that require that you use an include path to be able to correctly require files, you can also set that in your Composer package. We don't recommend that you use this because installing a lot of packages that all use the include path results in having a large number of directories within your include path, which is really bad for performance because every single include or require will have to check for the file within each one of these directories. As we install each package into a separate directory, this would mean it would have to check all of these using an include path on every single include, making it really slow to load files. However, this allows us to, for example, get backward compatibility with certain pair packages which rely on this behavior. So if you have some project that's already working like that, this is the way to get it working. All right, so now that you've defined this, as I mentioned, the Autoload PHP file is generated. And it's very easy to use. You simply require that one file. It takes care of registering itself as an autoloader. And afterwards, you can just start using all the classes defined in your dependencies. So it's the most simple way to just get started using a framework, using libraries. It's a single require line. And after that, you can just start using all of these classes and do things with them. There's a neat little trick. I'm not sure if everyone is aware of this. But if you require a file, you can actually return a value. And that's something we're doing in this autoloader. So the autoloader returns the autoloading instance itself, so you can then manipulate this further. For example, if during your testing you use a different namespace for your tests, which you don't want to make available for autoloading when a user is using your library, you can manually add this in your testing bootstrap file to the autoloader that Composer generated. And that way it's available during testing, but it won't be clogging up your namespaces when shipping to users. All right, so that's how the autoloading part works. Now we've seen how to install packages from Composer, how to use Composer to install packages from packages. We've seen how to use the autoloading, and we've heard that there are other ways to make packages available, for example, through status. But how do we do that? And it's, again, rather simple. Through Composer JSON, you simply define a list of additional repositories that you would like to load packages from. What's important to note here is that so far, when we've loaded a package, we've only ever specified the name and a version, right? We never specify where a package is coming from. All repositories are allowed to provide all kinds of names. So when you declare a requirement, you never specifically say where it's coming from. You can simply add additional repositories, making more of these names available with the appropriate versions, and they will be able to be used in your require lines. So additional repositories. The first type we have here is Composer. This is what packages itself provides and what Zatis generates. It's, again, a very simple JSON file that's basically just a list of all the metadata available in Composer JSONs for all the different versions of all the packages that you're making available in this repository. Alternatively, you can also directly specify something like a Git repository or an SVN repository, and it will automatically clone or check out that repository and check all the different tags and branches for Composer JSON files, and if it finds them, will make all of these versions available to use inside of your project. That gets a bit slow if you do this for a lot of projects, because it has to actually check all of these branches every single time to, well, it caches them to some degree, but it's just slow because it has to download all of these and look at all of them to identify these. It's very useful in development if you just quickly want to try something for a small number of repositories. But if you go bigger, have many of these, you should probably look into installing status, which is really easy to use. It's a single command that you run. It downloads these repositories and dumps a file, and you can just keep doing this, for example, through a cron job, and just have this sit somewhere that's available in your company. There are a couple other ways to install packages, for example, from Pair, but see the documentation for exactly how that works. The last bit I have in here is packages false. That's actually a way to disable packages. So if you don't want to use packages that are available in this large open source repository, but just your own ones, then you can just disable packages. One further trick that's available through repositories is actually requiring packages through Composure that aren't registered anywhere. So a good example of this is, for example, if you have a front-end dependency, say something like jQuery. They're probably not going to add a Composure JSON to jQuery because they really have no interest in doing that. They're not a PHP project. But you might want to still depend on that. And you would probably like to define this dependency in the same place that you define all other dependencies. There's a special type of repository that allows you to just define packages inline. So you yourself can specify all the metadata that they would have to put into their Composure JSON within your own one. And after you do this, there are a few special keys here for the dist specifies the download location, and the source a VCS repository. So if, as mentioned earlier, use something like prefer source, it would install the source URL, while the standard installation would take place from the dist URL. And that way you can just Composerify basically any project out there without having them to add a Composer JSON to their repository. At the same time, while this is kind of nice as a workaround, it gets rather annoying to maintain if you do this for a lot of packages and for many different versions. So at least for all PHP projects, we really just need your help with that. If you see one, you want to use it with Composer, and they don't have a Composer JSON yet, I don't know, send them a pull request on GitHub, or just ask them to add it. It's a really tiny file, and it's going to help a lot of developers use their libraries easier. It really has no downsides just having this one file in there. So just ask them to add it. In a lot of cases, they really quickly do. Sometimes they need a bit of convincing, but we just need your help with that. Yeah, I should probably mention this note at the bottom. If you do something like this in a package and you then publish it, and some other project you're working on uses this as a dependency, it will not be able to load this repository. But you will have to define it again in there. The reason for that is quite simple. Imagine on packages. All of the packages on there, in each of their versions, might define external repositories, which might be different for each version. To resolve this, you would have to go through all packages on packages for every single Composer install call, look at all of these repositories for each one of them, load all the packages, look at all of those packages, find all their repositories, and go on. And this would be a really slow, very long process. Instead, you would like to have all your metadata as quickly available as possible. That's why we do not allow you to define repositories within packages that you use as a dependency. So you can publish this just fine to packages, for example, but it will be ignored. If you want to use custom repositories, you will have to do so in the project that you are working on. All right, so that's like an intro into how Composer works. As I mentioned in the beginning, Composer is about a year old now. We're still officially in an alpha state, but we've had a lot of contributions. And if anyone here has helped us, thank you very much. If you haven't yet, go start. We have, I think, over 100 contributors at this point within this 1 year. It's really amazing to see how many people have chipped in and helped with this project to get it to the point where it is today. A few words on adoption. We actually have over 1,500 packages on packages today. That's an insanely large amount, and more than we would have expected within this short time frame. At the same time, if you look at something like NPM from Node.js, they have, I think, over 10,000 packages now, so there definitely is room to grow. And I'm hoping that a lot of you guys will submit your packages to packages, I don't know, maybe later today, next week, looking for more. We also had nearly 350,000 package installs within the last month, which again is a rather amazing number. It means that a lot of people are starting to use these packages through Composer. Yeah, stability-wise, we're still in an alpha stage. We're hoping to release a beta by the end of the month. It's not that big a deal, I think personally, because you're using this tool in development. So it's not something that your users will ever encounter in production. So it's not going to cause any running code to break. You might encounter the occasional bug locally. If you do, please help us fix these by reporting them to us. While at this point we've reached a rather stable state in most standard configurations, There are occasionally still things like proxies that cause problems with downloading certain packages, just configurations that we ourselves haven't come across, and we just need all of your help to make Composer more stable in these environments. Yeah, we have support by some frameworks, libraries. I think a really cool thing was the Facebook Php Sdk that added Composer JSON, where I think we had like 100 comments on the pull request from on GitHub from different people just going like, yeah, I want to use this as well. That was really fun to watch. And that's what I mentioned earlier. Just submit these files to people, and they're going to add them. It's great to just see this adopted in a lot of places. Yeah, there are a few platform as a service providers that have documentation on how to use Composer with them, or have promised us to kind of integrate it. It's not quite there yet, but I think it's coming. I've talked to Helge earlier of Engineered Orchestra, and they've been playing around with this and want to make it available to people to use. I think this is going to make it even easier if the platforms that you deploy your applications on are readily available, or have Composer readily available for you to use. So what's on our roadmap? A few things we want to add before we get to a stable state is handling of web assets. I mentioned earlier that if you want to use something like jQuery, you currently have to do something like this inline package definition. But we really imagine this should be easier. So we're trying to work out a way to maybe have a central location where we have a registration of all these commonly used libraries for the front end. We've been trying to work together with a few other package management tools and try to maybe come up with a common standard for this so that tools in Ruby, Python, etc. can use the same metadata to install these front-end things. We are not quite there yet. We're trying to work out how that might work. We have a few ideas, but that's going to come before we release a stable version sometime this summer, I imagine. Apart from that, as I mentioned, there's still bugs lurking here and there, and we need your help finding these, fixing them. Contributions are welcome. A lot of people have done so. Join us. Yeah, as I mentioned, on GitHub, you can find all of your stuff. That's where you report it. Right. Now that I've explained how Composer works, how it can help us get it going, I want to kind of outline what we're hoping to achieve with all of this. We want to change the way that people work with PHP. Rather than just thinking, oh, no, I haven't heard of a project that solves this particular problem I have, we want people to go and have an easy way to find these. Yeah, so it's no longer you must have heard about a project to be able to find it. And instead of writing it yourself because you haven't immediately thought of the project that might be solving your problem, there should be an easy way to find these packages. That's what we're trying to tackle with packages, making it easier to find already existing solutions to the problems that you have. So if you actually end up not finding a package that already solves the problem that you have, try and write small single-purpose libraries that solve just the one problem that you're currently tackling, rather than building something large that integrates fully into your application and that's just a huge monolithic mess that nobody else will be able to use. Try and identify small subproblems, solve those by themselves, and then share these libraries. Make them available as open source. Try and help others who have helped you by making their libraries available. We are all going to save a lot of time and money if we try and work like this more. If we reuse what other people have built and at the same time make our solutions as general purpose as possible so that other people can benefit from them. And I hope that through this and the large number of packages that is now available on Packagist and the strong growth that we have there, we will just change how you develop PHP, that you will no longer try and just build everything from the ground up, but that you start by looking, all right, I can use this thing, this thing, this thing, and then I really just need to solve my particular problem that I want to work on. All right, so these are a couple of URLs. Getcomposer.org is really the most important one. It's where you download Composer, where you find the documentation. Packages.org is where you find all of these packages. GitHub is where you find us. There's a Google group, Composer Dev, where you can ask questions and get help. It's also really easy to get help on the Freenode IRC channels, Composer and Composer Dev. There are a lot of people around there able to help you if you run into problems using Composer. All right, thank you everyone for listening. and go ahead and ask me some questions about Composure.
How do you handle when one package depends on specific versions of something else and another package depends on other versions?
Right.
What does Composure do at that point?
It basically, I mean, the assumption is that you can't install two versions of the same PHP package at the same time because of the way that namespacing and autoloading works. So Composure will tell you that there's a conflict. At the moment, the error output is a bit verbose. There are like a lot of messages. It's not quite that easy to understand. We're working on improving that a bit. But it will basically inform you, telling you exactly which two packages it was trying to install and why it was doing so. It will actually explain to you, you were trying to install package A and package C, and these two both had a requirement on package B, but one was trying to install this version and another one is installing this version. So we're trying to make that as easy to understand as possible so that you as a user of Composure find it easy to then solve this conflict by using maybe a different version of these two libraries. All right. More questions? I'll let in the back before you get the other one.
When you use Composure, is there a way to have your own packages in a separate directory from vendor packages? Because when I started using it, I noticed everything went into the vendor directory.
Right.
But I want a separate module directory and a separate vendor directory. Is that possible?
Yes and no. Like you can, well, for one thing, you can actually configure, like using, for example, custom installers, you can have certain types of packages just install somewhere else. In general, we don't really recommend that because in most cases, you want to have your, like the project's code in one place. And there really isn't a need to distinguish between where things came from. You can really just think of vendor my name as like your local packages that are from you. So in most cases, I would just recommend using the vendor directory. There's really no need why this would have to be called something different. And of course, the local code in that project is in a different directory. But yeah, I would really just recommend that you keep using the vendor directory. All right.
Lots of questions.
Sure.
So let's say your project might actually compose several different packages internally. Right now, you can only put the Composure JSON at the top level. Is there plans for sub-tree support at some point, or yes or no?
Yeah, well, there are definitely plans. I think there's even like a ticket open on this. We still haven't done that. Oh, you might. Yeah, I don't know. Like, there are a lot of ideas and things that we would really like to support. I mean, we're happy about help with doing these things. For one thing, we will probably start actually hosting packages on packages at some point, which will then allow us to have some sort of a build process. As soon as we have that, we can more easily do that. At the moment, we rely on packages having their download hosted through GitHub. So if you submit a GitHub URL, it will actually just give you the zipfile that GitHub generates. So we can't do anything like that. But we'll probably move to actually hosting these packages ourselves at some point. And at that point, we can have an intermediary step to process the package. So for example, you will always get your tests delivered with your code at the moment. So we're planning to actually add something like a Composure ignore file, similar to a git ignore file, where you can ignore certain directories and files that should not be shipped to users of your library. And as part of the build process, we will probably add something like, I really only want this one subdirectory, and the Composure JSON is in there. So we don't have that yet, but I really do want to add that at some point, yes.
Is that planned for the stable release, or is this whenever it comes out?
I would say it's planned for 1.0.0. I think it's tagged as such. So not the beta release yet, but like maybe like a later beta release is probably where I would expect this. Okay. All right. Any other questions? All right. In that case, we still have a few moments. So I've got like a bonus slide here with a few more advanced things that you can do. I just want to kind of point out that while Composure is really easy to get started with, like I showed, you can actually do some really cool, neat tricks with Composure. So this example I came up here is just some random packages that I just happen to be using. Is, for example, I want to be using this package called Symfony Monologue Bundle 2.0.10. Yeah, that's like a dependency I have in my project. Monologue is this logging library. And this logging library itself is missing this one key feature that I really wanted to add. And I've added that in a branch called my feature branch on my GitHub fork of that library. I've sent them a pull request, but they're probably going to take a while to work through that, figure out how my feature works if they really want to merge it. But I really want to get started using this feature right now. Now, I didn't actually require monologue itself, but I only used this one library which depends on another library which then itself depends on monologue. So the tree here, or the path here is monologue bundle requires monologue bridge. Monologue bridge requires a version 1 point something of monologue. So something neat that Composure does, or in fact packages does really, is it doesn't just look at your tags for versions, but it actually looks at all the branches in your repository as well. So if I add a custom repository to point to my Git repository, my fork, where I created this new branch, it will find my new branch and make this available as a version. That version is dev my feature branch. So you can just add something like require monologue dev my feature branch, and it'll use that branch. Now, we've got another problem here, which is that we're actually trying to use the monologue bridge, which requires 1 point asterisk. Now, dev my feature branch does not actually satisfy the version constraint that it's a 1 point something version, right? So there's something called aliasing in Composure, which allows you to install a different version as if it was that other version, so that further packages having dependencies on this will think that you installed 1.1.0, even though you really installed something entirely different. So that way, you can easily patch a single package within an entire graph of dependencies. Right? So if you can do this, you can imagine that there's some sort of bug in there, and you really urgently need to fix it. And this is like an easy way to just do that without having to wait for your upstream to merge that fix. At the same time, you can even think of this as a more permanent thing. So if you want to change some feature in there, and they decide that they don't actually want to merge this, they think this is not a feature that belongs in this library, you can actually just go off and fork it, and you would probably end up maybe putting the same package on Packagist, and you can do something very similar. Then you no longer need this repositories part. But using, similar to require, you can also specify replace in your Composer JSON. You could actually permanently say that this package is a replacement of monologue. Let's say I call my new library my logging lib. So I could say inside of the Composer JSON of my logging lib, I could just say this replaces monologue. And every other library that depends on monologue could then actually just use my library as well, and that dependency would be satisfied. So there wouldn't be an error that it has to install monologue, because my logging library is actually a replacement for that. This is sort of like some advanced things you can do with dependencies that are particularly different from things you're able to do with pair. If you imagine that you would have to do something like this with pair, it would actually mean that you would have to copy every single package that depends on some package, edit all of them, because you always explicitly reference a paired channel. Like, this is a key difference between Composer repositories and paired channels. When you define requirements, they never specify where the packages come from, so that you can do all of these neat little tricks. All right, so that's really it then. If you have questions about this, go ahead.
Does the version of the replaced library needs to satisfy the monologue version?
No, in fact, it's exactly like require. So when you replace a library, you specify which version of the library you replace. And you can replace a particular version, or again, you can replace a version constraint. You can say that my library actually replaces any 1 point anything version of monologue. Or you could say it only replaces 1.0.1. It works exactly the same way. All right, any other questions? All right, in that case, thank you again for listening. Go use Composure.
DPC Radio is a production of iBuildings. The materials presented are copyright of the speakers. This episode is released under a Creative Commons Attribution, Non-Commercial, No Derivatives 2.0 license. iBuildings is a full-service web development company specializing in PHP development. For more information on how we can help you with your next web project, visit our site at ibuildings.com. Thanks for listening, and we hope you'll join us again for DPC Radio.